SRE lead at HBO, so responsible for the HBO Go and Cinemax Go platform. We have, we're moving from that what everyone's doing, kind of moving from a monolithic app to microservices or service-oriented architecture. And we have a lot of tooling around that, and it's very interesting, and I could probably give 3 talks on what we're doing there, because it is, one, complicated and neat, and has its own challenges. But one of the things that I wanted to talk about was really more about sort of better improving the way we as sort of DevOps and sysadmins and SREs or whatever you want to call yourself, sort of develop our own work, right? One of the things that when I started HBO, they had like the boss was like, hey, I heard about something great, and this is sort of the story of like how we were able to use Ansible and Terraform to really try things out, be able to collaborate on something that's very complicated, where nobody really had any experience with this tool, and we were like 5 or 6, 7 of us were able to work together to build a pretty complete product, and just sort of how you can use it for anything, whether it's trying out a new tool at work, or if your developers are wanting to try out Ansible or learning how to use the cloud, you're migrating from your co-located data center stuff, and you want to try out stuff in OpenStack or Azure or AWS. So Terraform is a tool that can help you do that, and I think Ansible is a great companion. There's some overlap in what they do, and then I'll talk about that a little bit. But I'm calling this using Ansible and Terraform to try out that new toy. And I hope everybody can see okay. And the other thing is, real quick, I'm going to be jumping back and forth between a terminal and my slides as I kind of give a demonstration. So I don't know if it was like this for everybody, but in the last 15 years as I've been doing this, this is a lot of times what it was like whenever your boss said, hey, I heard about product X, whether it was a new monitoring system or a new database or a new application server, whatever it was. It was usually like the sysadmin, go make this work, like go and figure it out. And how did this work usually? Like, okay, I got to go find some servers. Maybe there's an old laptop. I start kind of playing around there, and I'm starting to read the docs. Okay, what is it do I need to do? I try installing the software, and then there's a set one outage, and 4 days later I come back to my work, and what was I doing? Spent another week, again, reading docs, trying stuff out. I've been working on this one server for 2 weeks now, and I just got it out running. Oh wait, now I've got to go help fix another critical problem. And by the time you're back, it's time to hand it off to like your junior admin to hopefully try to put this in production, right? So those are the horrible days. I think we're all trying to get away from that, but a lot of times when you're working with third-party products, as an example, I was asked to help install Jira, right? Like, that's stupid. I don't want to do that. That's a ridiculous waste of my time. But what we did do is we used it as an opportunity to try out something like software-defined infrastructure for Jira. How do we automate like everything from deployment of Jira, from spinning up its services, its RDS instance, its EBS volume, to deploying the software so that if the server ever goes away again, the Jira admin can run a Jenkins job and have his Jira server back, right? And when you think about it like that, well, there is really a use case for even software-defined infrastructure for stuff that isn't your own product or isn't necessarily open source. In this example, I'm going to, so this is, I don't know if this happened to everybody else, but this is how it usually happens for me. Like, the boss goes away to like Napa Valley on a great conference, and somebody told him about project X and this product Y, and this is why you should, going back to my user story, like I wanted to avoid it this time when the boss came and said, hey, do this, right? And so the way you used to do it, right? All right, I do all my work, and then once it was time to wrap it up and document, I'm like looking through my notes and my batch history, and those things don't scale, they don't work well. You can't collaborate with other people that way. So when I started HBO, I said, well, let's start with something like Terraform that automatically puts our infrastructure as source code. But yes, we use Ansible, but we weren't necessarily using Ansible to define our AWS infrastructure or do a lot of that, and it's totally capable of doing that. And I will give another presentation on why you can use Ansible to do all of this and how to do it. But in this case, like, there's some really great parts about Terraform. So again, it's as you're doing this when you're developing a new service or a new product or trying out new technology, treating it like a software project kind of has some inherent goodness to it, I guess, right? So if you start thinking about it as a software project, you're automatically starting to use an SCM, even if it's just to put in some configuration files, right? Like, now I can share this with other people. I've got a history of what happened. Like, why did I change this value? Well, here's my commit message. Like, here's the difference across time. You kind of see that. You can always repeat and validate your work, so that even if 3 different people are working on how to stand up an Elasticsearch cluster, between SCM and something like Terraform, we can exchange ideas, we can try different things, but we can also work independently, like you would as a software developer with your own, sort of software development environment. Using these tools, you can, automate this so that you can then include continuous integration, continuous delivery. As I'll kind of show you in the demo, it actually is in your best interest to always be destroying and always redoing your work, and it really hits back to Alex's point about even before you're into production, you're already doing this all of the time, and the process will be that much better by the time you actually roll it out in production, right? So, and then again, with sort of this culture of openness, right? Anybody in the team or the company can follow your process and help collaborate, right? So. HBO is a very large company. We have lots of different teams. Once we started work on an Elasticsearch solution to replace Splunk, now we have our platform team that's very interested in this, and we can easily collaborate with them, and they can work with us on setting up Logstash components or improving our Elasticsearch indexing. So this is going to be a very quick and incomplete introduction to Terraform. Has anybody here used it before? Cool. Yeah, so there's a whole lot to it. I've been using it a lot for the past 7 months, and I still feel like I'm pretty new at it, and it still bites me from time to time. So I guess my warning is use it, play with it, and when you think you're ready to go for production, wait another 6 months, because you're probably going to find some other stuff, and then you're probably ready to go to production with Terraform. But it can be really great for development. For me, it has kind of replaced Vagrant in a lot of ways, especially when I'm not just writing up some Python, right, in Vim. If I need to test multiple systems, if I need to test network connectivity, even testing your infrastructure is now easier. If your infrastructure is in Amazon and you have to worry about, did I set up my security groups correctly? Did I have my IAM roles or my IAM profiles correct? Things like Terraform, give you the source code and can show that, and then again, you can run it over and over again in different environments to validate your configuration. So let's see. So let me just show you some Terraform real quick. That is, yeah. Okay, that helped. Me.
Apple Plus.
Yeah. Okay. Is that real? Not really. Still.
2 more. 3.
All right. So.
1 more.
Still 1 more. Okay. All right. All right. So this is defining an Amazon resource via Terraform. It is not. So it's sort of, they call it HCL, and I forget all of the terms, but this is their domain-specific language. Terraform is multi-cloud, so it will work with most cloud providers. It can work with things that you wouldn't really consider a cloud, such as GitHub, to be able to manage even your source code project with your source code repository with your own project. I think that's a little crazy, but to each their own. So this is an instance. Let me show you my directory. You can kind of see from the directory here, you can put in Terraform. You can put all of this in one file, kind of broken it up based on what it's doing. So let's see if we can. Right. So this is what a security group looks like. And the beautiful part is now I'm just going to build all of this, and then I'll go back to talking about stuff while this builds. So it only takes about 2.5 minutes, so I won't have too much time. But let's see what I can talk about. So yeah, so some more about Terraform. It really is an opinionated way of doing infrastructure as code, and I use the word opinionated strongly because if you don't like the way they're doing it, obviously you can work on the project to try to change it, but they have a very specific worldview about how to treat infrastructure as code that not everyone agrees with. So if you're, just be aware of that. It's multi-cloud aware, like I said, OpenStack AWS, Google Compute, Azure. I think there's Heroku and on, just basically anybody. So I mentioned Elasticsearch, Logstash Command. This was my boss's great idea when I first started, and I don't know how familiar people are with Elk. So I said it's hard and it requires lots of changes and it's lots of resources, and that's that's sort of true if you're like a big enterprise type place. Like if you're kind of a small place, like you're probably thinking like, what am I complaining about? Like it's still pretty easy to do. But to give you an idea, like HBO wants to be able to ingest, their platform logs, or in upwards of 2 to 3 terabytes a day. So it's not like big data, but it's certainly more data than just sending it to Amazon's Elasticsearch service, right? So it's kind of like that in between. You got to really build something. And the other thing is, in a place like in an enterprise environment like HBO, you have to be able to collaborate, coordinate with lots of different teams. So as part of that stack, right, we're asking teams to be able to either send logs to multiple locations, or maybe even preempt that log process. And how do we do that without breaking it? A lot of similar challenges to Alex, right? So, this is really just about trying it out. Like, again, I'm not going to tell you how to build a perfect elk stack or anything like that, but this is just sort of how we got started with it. How we started using Terraform and Ansible together to build a product. So here's what we did on the first day, right? So somebody says, all right, you should build an elk stack. So a lot of people go out and say, okay, great, I'm going to go read the docs, I'm going to do a whole bunch of stuff. And sure, that's great, but let's start with the infrastructure. So the very first thing we should do is create a repo. So in this case, we're using, I just created a GitHub repo. I think Bitbucket's fine. If you're using Subversion, I'm sorry, but it totally works. For those of you that don't do a lot of who are maybe still kind of getting used to more of a software development type life cycle for your infrastructure, some of the do's that I like, branch often, especially when it makes sense for features or specific goals. You don't want to just do everything in master. It's a really good way to get yourself in a knot. Commit early, commit often. If you made just a few small changes, as long as they're sort of all logically together, it's really good to just commit that right now. Get that while it's in memory. Put your message in the Git log so you can move on to other work. And then I recommend using pull requests or other code review techniques. This is really helpful because on my team especially, we had like 5 people doing this part-time. So nobody's working on this part-time, but you still wanted to keep other people interested in what was going on. So we rely on pull requests to keep other people informed, people to test stuff, review your code. Everybody is aware of what's going on within as everybody's developing it. So while one person is working on sort of the master client node configuration, another person's working on the sort of the index mappings and that sort of stuff. And again, they're working together. They're working independently with these tools and using SCM. So hang on. So here's our source code repository. It's called an Ansible-NYC demo. Right. So what did I do? I created just a kind of a blank Terraform stuff. So let me go into the specifics of what we're doing here with Terraform. In Terraform, we're creating a VPC. So if you're not familiar with that, it's sort of like having your own private VLAN where you can, segment that off, create subnets and stuff like that. And then some IAM profiles, some security groups, and then back to sort of our compute resources. We're creating 4 EC2 instances: 2 to host Elasticsearch, 1 to host Logstash, and 1 to host Kibana, right? It's very simple. The user data is just update packages. We're not doing anything. We're just using the Amazon AMI. Very simplistic. The only way I'm cheating is that I have an account at work set up, and that's kind of what I'm using right now. And in fact, I need to turn my VPN so I can finish this. And then we're not doing, you can do all sorts of crazy stuff with a local provisioner, where you can have Ansible do stuff, or you can have an Ansible pool done when you can bring up the server. But just for simplicity's sake, we're just kind of creating infrastructure and then pushing Ansible. So here's what we created. Like I said, 4 instances. I printed out what our private IP address is and what the public IP address is, and let's just see if they actually exist. I hope so. Yes, there we go, 4 instances. You'll notice I'm using a tag, and the tags will come in, will be very important later on. But just as an example, here's the tag, and that's really hard to see, guys, but I need to say anything. Yeah, so the tags will be very important. Since again, this is all on Amazon, we're not sharing there's no way for Terraform to send information to Ansible. Ansible is ignorant of Terraform, so we'll use these tags to really figure all that stuff out. Let me zoom in again on this one. So now I'm just going to okay. So that's my Terraform environment. I now have 4 computers. They're just sitting there idle. What are they doing? So now, all right. So pardon me, guys. All right. So yes, this is our step. We created our virtual hardware. I created a VPC with the networks, so a subnet, security groups, and then we created 4 EC2 instances. So next we need to create Ansible roles, right? So, but why? Like we have Ansible Galaxy. In particular, this user Gear Lingdai, he has an amazing amount of really good quality Ansible roles. And so anytime I try something new, I always go to him first. And as you can see, he's very prolific, and but he has a role for Elasticsearch, he has a role for Logstash, he has a role for Kibana. So the nice part is, like, again, I'm not here on the first day to try to make a perfect Elasticsearch cluster. I just want something where I have a test environment where we can get something working, and these rules from Ansible are usually a good sort of scaffold, I find. At the very least, they kind of show you what should be done in a best practice way, and then it's your job to really fill in some of the blanks, especially as it relates to your environment. And this is what we're going to be doing throughout this process of testing and rapid iteration. So. Sorry, so here's the cool part. One of the things I didn't show is that there's an EC2 inventory script, just called ec2.py, so that's what I'll be using, and I'll show it to you guys later, but that is what goes and finds all these instances based on this limit that I'm going to give it. Sorry guys. Going to run, and I'll show you my site.yaml right now. This runs because when ec2py runs, it takes a very long time for it to look at all of the instances in your environment. And there's some other things you can do to get around this. But again, this is our first day. We're just trying this out. So let me show you some of the Ansible stuff. It's very simple. Our site.yaml. It just does a few things. It gathers EC2 facts. It gets a list of tags, and then it groups by role. In this case, it's by the environment key. So I did do that one. And then I just include these roles. When the instant tag role is Elasticsearch or Kibana or Logstash. And this way, I don't need to know anything about any of the underlying systems. I don't need to know their IP address or their host name or anything like that. But apparently I did not get limits. Hold on.
Ansible-NYC-down.
Yeah, unfortunately, it converts it all to underscores, so that one also kind of gets you. So, all right, great. So we found some hosts we're going to run. So again, this is the first time, right? This is from the point of view of hopefully yourself. Okay, great. I copied this stuff in. I'm using these generic roles. What happens? Now this is a presentation, so I know what happens. Hopefully it all goes well. But see, again, these are all just things straight out of the box. I have the link to my repo in the slides. When you look at the slides, in my notes about how to create all of the stuff in Terraform, I give you the link. I copied it from someone else, right? Like this is the minimal way to set up a VPC. You'll have the link for that, and you can go home, put in your AWS account, and create your own VPC in your account, and be up and running this within a few minutes, 2.5 minutes actually. So so what are the advantages here, right? So if it takes me 2.5 minutes to spin up an environment, well, now it makes testing things individually and in isolation very easy and very rapid. So it's obviously not as fast as Docker, but it does give us that more real world feel in that I have multiple systems that need to interconnect with each other and talk. And for services, a lot of third-party services, you're not likely to get them as a Docker service or a Docker container anytime soon anyway. So, a lot of times you have to still work in the real world of like VMs or server hardware. All right, so we ran. Oh, something failed though. What could it be, right? So again, this is all just defaults. I haven't said anything in group vars. I haven't said anything for my environment. This is just the very defaults because I have no idea what to really expect. So fortunately though, I do know what happened here. Again with that, but so when he was copying his Nginx config in this role, the owner of the role, the author, kind of made some assumptions about Nginx kind of being there, and so let's see, he tries to change something as this Nginx user. Oh, well, I didn't set that, so let me set that really quick. Oh yeah, and by the way, when we're making changes, we should be creating a new branch, right? So I'm going to create I have so many shortcuts, sorry guys. But this is just a checkout with a new branch, and I'll call it, demo fix bug. Sorry. Okay, great. So now I'm in my, and I don't know if you guys can see it, but I list like what branch I'm in as part of my bash. Okay, so I'm going to fix that task really quick. Or not fix it, but sorry. Also, I'm just going to say Nginx. I'm just using I know it's installed, and I'm cheating, sorry guys, but this is all for the sake of convenience. So we'll rerun it, it'll all work, great. Now I think I have something, right? And then once this works, we can go through checking it in really quick, and so that's great, I've got something. There's some sort of software running. How do I know what I have? What am I supposed to do now? And so this is where I think Ansible really plays a great role, right? So, so some of the things I like about Ansible is that when it comes to sort of testing your work, at the very minimum, you get some feedback right away from Ansible, right? You get a success or failure. In this case, we had 3 successes and we had 1 failure. Like Elasticsearch at least installed itself properly, it started up. Logstash similarly, and we had a problem with Kibana, and now hopefully that's being fixed. All right, but what about testing with Ansible? Because at the same time, again, how do I know? Like I'm still kind of figuring this out. So I go and I read the Elasticsearch documents, and I start looking around. Okay, I've installed it. What do I do? Oh my gosh, it's still doing. Wow.
I've never had it before.
No. So and so again, like we can keep iterating over this, figuring it out. And again, what do I get out of this? Every time I do a commit, again, I get that history of what I was doing. And when somebody else goes to look at it, they can see exactly what I did, why I did it, when I did it. And you iterate through this process. So I'll do a git commit, -m, fix Nginx user definition or something, right? Oh, we're done. And, so, but to get to testing, let's take a look. Like, how might you test? So one of the things that I've been playing around with is just sort of using Ansible to do tests. So here's 2 that I came up with just off the top of my head, right? So I've installed Kibana and I've installed Elasticsearch, and they should both have a port open and running, right? So Elasticsearch should be listening on port 80, Elasticsearch should be listening on port 9200, and Kibana should be listening on port 80. It's a web server, web service. So just kind of rerun my Ansible playbook here, but we'll run it with a test and doing the tests instead. Again, very similar. I guess EC2 facts, exactly the same. Oh, but it all failed. Huh. Turns out, let's see. It failed earlier for the right reason, which is the services, the ports are all listening on localhost because they've not been configured to actually listen on any of the interfaces. But this is a different error. So, huh. I don't know why I'd be using sudo. I'll have to take a look at that. But again, so now we can use things like the URI module or the get URL module to help test web services, right? It's something up and running. Again, very basic, very minimum. And you can keep adding on to these tests. So there's strategies like adding a test directory, similar to how your service code might also so if your application developers write unit tests, which they hopefully do, and functional tests, right? They put that in a test directory. You can do something similar for the infrastructure. Let's see, and then so that was really it. This is again like I originally had said, oh, I'll come up with like 5 different things we could do this, and then I realized when I was talking through it, it was going to be like 4 hours, so we just did this one. But the point is, like, you can take this sort of process and I think apply it to any sort of software, even software you're writing yourself or within your company. And tools such, it doesn't have to be Terraform. You can use CloudFormation with AWS. You can use, you can write your own. You can use Ansible. All these things work, but what's really important is to be able to, constantly be able to quickly stand up in an environment and do this over and over and over again. Just practice makes perfect. And then, once I'm done, like, gosh, I can't figure it out. Whatever, I'm done for the day. I can just destroy it all and go home. So we do a destroy. And now I have no mess. And when I come back tomorrow morning, again, I'm not going to have any artifacts left over when I start at 8 a.m. I build a new environment and we start again. And we can do that every day. And we don't have to worry about, what did the other guy do on this one server that he didn't document? Like, all of that stuff goes away because you're doing this over and over again. So, yeah. So let's see, let's go back. So we're destroying, and really that's it. Yeah, so some links from the slides. You can review Terraform. We can read the Elasticsearch documentation, and you can also check out this demo on GitHub. So I'm happy to answer any questions. I didn't want to get too specific into Terraform per se, but I just kind of wanted to show it as an option as you guys do this. But I'm happy to answer what I can.
So thanks for the talk.
Sure.
So you mentioned like the first thing you do is you create like a new repo, right?
Yeah.
What if you need this cluster to interact with another cluster, and like we need to manage more resources through Terraform than just
sure.
one little section?
So okay, yeah, we can talk about that a little bit. So there's in my usage, I've sort of found 2 use cases for Terraform. One is Terraform as my infrastructure definition for the application that I'm writing. At HBO, we write everything in Node.js. All of our backend services are JavaScript. And one of the things that we do is, for every service, we have a deployment directory. That deployment directory describes what the infrastructure should look like for all of the various environments, right? And so Terraform is very powerful in that regard. You can specify just the resources you need for your application, and then you use things what are called state files to share information about other states within your Terraform world. So one of the things we're working on now is a centralized, so we'll kind of have the centralized and distributed Terraform configuration. Terraform, the central repository, will control the central infrastructure things, VPCs, IAM profiles probably, all of the routing, like VPNs, NATs, like all of this sort of stuff that doesn't change very often and is shared by every service. And then each individual service can say, well, I need 10 C3 larges, and I need an RDS cluster, and I need an elastic cache service, right? And that's where they would define all of that within sort of their own project. Does that make sense? And then if they needed like a VPC ID, we have a standardized path in S3 for our state files, and you can just import that as a resource, and then you can read the outputs of that state file into your Terraform file. Yes?
So you are using Terraform in production?
We are not using it. We're using it in production, but where there are already existing services running, so that if something bad happens now, we're not out completely out of the water, right? So in this case, Elasticsearch. So we have Splunk. Splunk is still our primary log aggregator and all of that, and we're phasing in Elk. And so things like, well, I didn't know this one change would actually cause a destroy and then a recreate. Like, we can sort of figure those things out now, right? And that's what we're doing is like, what are those gotchas? Working on some Python tooling to help with blue-green deployments, to sort of add in some additional checks and some sanity checks. So, Terraform's great, but it's all powerful, and so you have to be very careful. But it is coming along, and we're sort of developing these standards. The other thing is that this tool hasn't been around for very long, and so the community itself is still trying to figure out like some of these best practices. HashiCorp is still trying to figure this out. They're changing pretty rapidly. For instance, since the start of Terraform, I don't know if you're familiar with modules. Modules are kind of like functions, and so you can sort of say, like, one of the things we could do once we're ready for production is I could define this entire Elasticsearch cluster as a module that you then just import, fill in some blanks, and it builds the cluster. But you can only pass strings. Well, that's really annoying because a lot of times I have lists, or I might have a map, which is kind of similar to a dictionary, right? And you have to like do all of these things to manipulate the data. And now they're like, oh, you know what? That is a really bad idea. So in the next version of Terraform, you're allowed to pass like lists and maps and stuff like that. So it's changing a lot. It's still finding its footing, but I think it's very exciting. CloudFormation for AWS is probably a little bit more mature, but especially if you're not using AWS, like there's nothing else really out there without rolling your own system, especially if you're trying to use something like Google Compute, which isn't necessarily like all their cloud providers, right? I haven't tried this with OpenStack. I have my doubts about how well it really works with OpenStack, but who knows? Maybe it'll be awesome. So,
quick follow-up question. So you kind of described like a hub, like kind of like your central hub and spoke. Like,
so the other thing to keep in mind is, so with Terraform and state files and keeping them in sync, it's really it's not even important. It's mandatory that you have a central process to do this, whether it's Jenkins or Travis or some other pipeline that you built. As you're building stuff, it's totally okay to share state files because you can sync state files to S3 or console or a number of other data stores, and other people can resync it to their local directory, and you guys don't override each other. But as teams grow, as the environment becomes more complex, the likelihood of somebody forgetting to do that pull or forgetting to do that push increases exponentially, probably even higher, geometrically. So use Jenkins. Use something that manages all of this. The other thing is that you can't, like with the free open source version of Terraform, you can't lock a state file. You get that if you use Atlas, but so you need some sophistication and you need some tooling if you really wanted to take this into production. Yes?
And in production, have you run into any issues where you try to automatically run your Terraform code and there was some modification that somehow made it?
Yeah, so that's a great question. Sorry, please finish.
So essentially Terraform thinks that it should look this way.
Yeah.
But someone else modified it to make it look different.
Yeah.
Now you have trouble running here.
Yeah, sure. So actually that's part of the thing we like about it. That's part of the validation, so that we can go and say, who changed this, right? So I have my Amazon history. I can say, why did you change the security group, or why did you do that? Terraform's gotten a little bit better about that. Some things, like for instance, auto-scaling group capacity, like if somebody modifies that manually, doesn't necessarily break Terraform anymore, whereas it used to be like anything was different from the state file, Terraform would stop. So it's getting a little bit better about that. But yeah, no, we actually use that as part of the validation. So the idea is that we run a Terraform apply as often as possible, hopefully every day, but hopefully more often as we become more comfortable with it. And then if it breaks like that, then we know sooner rather than later that somebody made a change, and we don't have it documented. All right, guys, thanks. Oh, yeah, go ahead.
Just a quick question. In the past, I've kind of used the EC2 module in Ansible in the same way they use Terraform to kind of provide an infrastructure. And over the past few months, I've been playing around with Terraform, and I've kind of found the line between Terraform and Ansible. I've been able to push it more and more, like especially if you put your application in really all you're using Ansible is to change which container you're running.
Yeah. So there is some overlap. You know, when I was discussing, I think it was Steven earlier about, you know, why Terraform over Ansible, and so I actually used to do a lot of this stuff with Ansible, but what it really boiled down to was Terraform is just much faster at it. It can parallelize the things that you can't with Ansible, or you can, but it takes a lot of, it's challenging, and then also manages dependencies, which you actually can't even do that. Like, you have to know to create something before something else when running Ansible. There's no dependency checking, there's no dependency graph. And so this kind of helps you. Like, I can make this Terraform file any way that I want it, and Terraform will put it into a graph that makes sense. There are some, but so to your point, yes, especially as you're writing your own software, more and more people are going to be deploying their own software as Docker, and I think that will definitely change how people use Ansible for their deployment. But I still think there's a lot of quality, sort of, I hate the word synergy, but ways they can be used together. Again, more in the enterprise world where people are kind of stuck, like, I have to support Oracle. Holy shit, like, you're gonna throw that on a Docker image? Like, no, but at least I can spin up an RDS cluster in Oracle, right? Or an Oracle RDS cluster in Amazon, where I can spin up the instances and manage all of that stuff, and then, like, just let the Oracle stuff be by itself, and I don't have to worry about what server settings did we put for shared memory. Oh, we forgot to write it down, and we didn't store it in configuration management. There's still, I think, a huge win there. So, and again, like, I think also when it comes to rapid development and prototyping and stuff like that, obviously Docker, again, makes those things easier, but it's still not quite the same. Again, unfortunately, more with the sort of people that have to use other people's software, right? Yeah.
So do you see yourself kind of, though, moving more of what you do from Ansible to Terraform, or do you think they're kind of pretty clearly delineated?
So let me explain. Like, so at HBO, the way that we do it, we have a whole huge pipeline. It's some Python wrapped around Ansible, and so this is the old way. This is actually going away. You're absolutely right. We use so somebody says I need I merged a change into master for some service, and there's a whole huge pipeline. I've got tests, unit tests, functional tests, and I build a staging environment, right? And then I deploy the software, and I do a whole bunch of functional tests and more unit tests, and holy cow, is it okay? Somehow, 45 minutes later, all of the stuff gets through, and it pushes to production. Well, what happens in that? Part of that is every time we deploy a new application, we have what's called like a base AMI, and then we use Ansible to install the application on top of that and build yet another AMI, and then that's what we ship for our auto-scaling groups. So yeah, until we use Docker, you still have to do those types of things, right? You'd still need to use Packer if we weren't doing this ourselves, right? So, and how do you get Packer to the way that you want it? How do you get, and so yeah, yes, it will change with Docker, and you may not be using it as much for your deployment orchestration and your deployment configuration, but you still have to configure your Kubernetes cluster, you still have to configure your Mesos cluster, you still have to, you know, again, a lot of services are not going to run very well in Docker, so, you know, what about all of that? So, yes, it will change, and it'll be different, and that's okay. They can both run at the same time in the same place, and what I love about Ansible and both of these systems, again, is that while Terraform is not as readable as Ansible, I think it's still readable by somebody who is not some hardcore AWS engineer, right? Like, a programmer can read that and say, okay, that's an EC2 instance, I know what that is, I know what a security group is, I know what an IAM profile is, and all of these things make sense, and they're self-documented. So, yes?
Just for the sake of brains, that one of the pain points that I have using Terraform for a small project, which you can't import existing resources, and although there are some third-party, I think there's like a third-party tool for creating a state file for you that you can use. We didn't really go into this too much before, but what method were you using for existing resources? You said you were skipping over them in some way?
Yeah, so, so, yes. Terraform, HashiCorp tells you, do not try to use Terraform for existing resources, right? Like, again, HashiCorp and Terraform is very opinionated, and they want things done in a very specific way. So it's not in their best interest to try to figure out what craziness you did previously. That being said, I still have an existing AWS account. I still have a VPC. I still have networks. I still have security groups. I still have IAM profiles. All these other things exist. So I think I talked about sort of these remote state files as a source of information. So what we did was we actually generated sort of dumb Terraform files, and we did it sort of hierarchically. So we have information that's available at the AWS provider level. That is, and we have multiple accounts, so that a Terraform run can get this information that applies to all accounts. This is a pretty simple list. It's like a list of VPN IP endpoints. It's a list of sort of trusted corporate IPs, a couple of other things. There's not a whole lot you're going to share between accounts. And then we have, in that state file, all we did was we put in this list of IPs, and in the Terraform file we said just output this variable. But if I need that list, I can just import that state file as a resource. I know the name of the resource. I use it as a variable within my own Terraform file, and I have that list. After the sort of AWS provider, then we sort of start having things that are account specific. Those are usually like things that are going to be global across an account. And again, all we do is we just create a list or some variables that say, here's a list of zone IDs for Route 53. Here's a list of already created IAM profiles. Like maybe we have something like generic EC2 IAM profile that we use for everybody. And we just put that IAM profile name and ID as a variable, and then we can, again, import that. And if the thing already exists, if you give Terraform a VPC ID, the actual ID, it's totally cool with that. It can go out and then, make changes to the VPC ID. Well, not make changes, but take that value and use it in something like an ASG, like when you're setting up where it should run, or an EC2 instance. And that's totally legal. A lot of people, if you don't use state files, one of the things that we're looking at is storing all these variables in something like etcd or console, and then when we're running Terraform apply, using the command line overrides to set all of these variables at runtime. We're still kind of like, is it easier to keep all of these state files and figure that out, or is it easier to just have like a key value store somewhere with sort of a same namespace and programmatically figure it out? And so those are some things we're kind of looking at. Again, things like VPC IDs, subnet group IDs, that sort of thing. So, but yeah, you cannot just take an existing resource and start managing it with Terraform, unfortunately. So that is a big challenge. But again, with the learning curve of Terraform, I would never recommend that anybody ever do that, right? Because that's really easy to accidentally just destroy it all. So, yeah.
Could you use Terraform plan to kind of iteratively get there? Like maybe take a best guess and use Terraform plan because it'll give you the changes it'll make, and then maybe the changes you might say add this or delete this, and then you can change the state file and Terraform plan again and see if you get any closer. I don't know.
So to Steven's point, there's actually a GitHub project out there that does try to read like your Amazon environment and create a state file. The state file itself is like JSON. So there's nothing, and it's completely human readable. So if you sort of knew their underlying syntax, and you could probably look it up in the repo, you could totally just fill out your own state file. And there's nothing preventing Terraform then from starting to manage it other than your own sort of like suicidal tendencies. So
yeah, be very afraid, right?
So cool. So we're at 8 o'clock. I have to catch a train. We got to clean up. Feel free to stick around, have a couple beer. We'll have a beer. If we have pizza left, help eat that. And if you guys want to chit chat, we've got a good half hour, I'd say. So thanks, guys.
Hi, guys. My name is Natalie. I'm a recruiter here at Offerpop. I know that Connie and Eugene did a great job telling you about our DevOps role we have open. I'm sorry I couldn't be here in the beginning. I was busy at an Offerpop happy hour. It's really hard to say no to free booze, especially when your company's paying for it. So I'm a little late, but I'm gonna leave some business cards on the table here. If any of you would like to connect, send me a resume, send me a friend who's amazing and might be interested, or just, for future connecting on LinkedIn or potentially getting free booze on us again sometime. So these are some business cards. Enjoy the beer, enjoy the food, and thank you for coming.
Yay.